friends, myself Jarnail Singh, PGT Physics, Malerkotla. Today I am going to discuss defects in vision and their correction. So first, accommodation of the eye. Accommodation of eye is the ability of the eye lens to change its focal length with the action of ciliary muscles in such a way that sharp image is formed on the retina, that is known as power of accommodation. Next, what is near point? The least distance up to which an eye can see object clearly, also called least distance of distinct vision, and for adult or normal adult eye it is 25 centimeter. So say this is eyeball. Now here the distance is 25 centimeter for an adult. Now this is the distance from the lens, and it is also known as least distance of distinct vision. Next, far point. The farthest distance up to which an eye can see the object without strain is called far point, and for normal eye it is infinity. Say this is a normal eye, and for normal eye the far point is infinity, that one can see any object which is at infinity. Next, short-sightedness or myopia. Now, what are the causes? These are defects. First defect, and the cause of this defect is the length or size of eyeball that increases. Here, the length or the size that is increasing, and the focal length of the eye lens is decreased when eye is relaxed. When eye is in the relaxed mode, then the focal length is decreased and image is not formed at the retina. Now how it is corrected? Now we can correct this defect by using a concave lens of suitable focal length, and we can see that here the far point that is at infinity. When the lens is not there, then this far point is at this point O, but we have corrected by using this concave lens. Next, long-sightedness or hypermetropia. So long-sightedness is that when one can see the long distant object but cannot see the near one object. So this is also called hypermetropia. Now you can see the image formed is behind the retina and one cannot see the object clearly. Now what are the causes? The size of the eyeball becomes so small, and that is the distance of the retina from eye lens decrease. So the focal length of the eye lens that increases when it is relaxed. Next, corrected eye for hypermetropia. How this defect is corrected? So for this correction we use a convex lens of suitable focal length. Now before that, when the lens is not there, then our near point is here, but when we use this convex lens, then the near point is there, that is D, it becomes 25 centimeter. Next, correction. The correct myopia, a diverging lens, that is concave lens, is required so that image is formed at the retina, and the formula used for correction, that is f is equal to minus x, where x is equal to the image distance. Now we can use these formulas for the correction. Next, the far point of a person. This is an numerical. A far point of a person is 100 centimeter in front of the eye. What is the nature and power of the correcting lens? Say one person is there and the far point is for that person is 100 centimeter. So we can use that formula. We are given here u is equal to say alpha and v is equal to minus 100 centimeter. Then using this lens formula, 1 by f is equal to 1 by minus 100 minus due to the sign conventions, and minus 1 upon alpha. We u is equal to alpha. So 1 by f is equal to 1 by minus 100 minus 0. 1 by f is equal to 1 by minus 100 and f is equal to minus 100 centimeter, and which is equal to minus 1 meter. So here minus sign show that the nature of lens, that is having नेगेटिव फोकल लेंथ, एंड नेगेटिव फोकल लेंथ जो है वो किसकी रहती है, कनकेव लेंस की. नेक्स्ट, करेक्शन ऑफ myopic eye. To correct hypermetropia, a convex lens of suitable focal length is required, and formula for that correction we use is f is equal to xd upon x minus d, where x is the object distance, that is distance from the center of the eye lens, and d is the distance of distinct vision, that is 25 centimeter. Now we can discuss near point of hypermetropic eye is 100 centimeter. Assume that near point of normal eye is 25 centimeter. What is the nature and power of the the correcting lens? The eye defect can be corrected with the help of convex lens. Here u is equal to d and d is equal to minus 25 centimeter. U is the object distance, which is representing here by capital D, and for normal vision it is minus 25 centimeter. Image distance V minus 1 meter minus 100 centimeter, and using lines formula 1 by V minus 1 by U is equal to 1 by F. So substituting the values, 1 by f is equal to 1 by minus 100 minus 1 by minus 25. We have taken here minus and minus क्योंकि this minus is already there and this minus is by using sign conventions. So 1 by f is equal to 1 by plus 25 minus 1 by 100, and f is equal to 100 upon 3, that is 1 upon 3 meter. Now power of a lens. Power of lens P is equal to 1 by focal length in meters. So 1 upon 1 by 3 is equal to plus 3 diopter. So note always shows power of lens with sign conventions like plus 3d. The power is always shown with plus or minus sign so that we can understood that which is the nature, that is which type of lens is there. Thank you.